We'll now talk about strings. So as mathematicians, you might think that strings are not very useful, but that's not really true. Strings are important when you want to communicate with humans. So when you want to take an input or when you want to explain some output, that's one aspect. Strings are also important when you want to communicate between computers or between files on your programs. And finally, strings are a very efficient way of storing information. They're very versatile. You can do a lot of different things, and the strings help you do that. So there are lots of methods, lots of functions you can call on strings, and we'll see some of them now. So let's see what we can do with strings. The first thing we can do is we can create them, of course. So here, with a double quote, we're creating an object, which is the string of letters from A to J. And we're binding that to the variable data. Once we have that variable data, we can decide to print it, and this prints the content of the string. We can also just type data, and the interpreter will do its best to print everything that it knows about data. Now you might think that it will print exactly the same thing as the preceding line, but that's not true. What will be printed is this. So as I just said, it will do its best to print what it knows about the variable name data, or what it's bound to. And data is bound to a string whose content is all that. So what the interpreter is indicating here is that the content of the string is that, and this is in blue, but also that this is actually a string. So that's why it's surrounding it with single quotes. When you do print, it's expected that the input here will be a string. So it doesn't need to indicate it anymore. And it doesn't want to actually, so it doesn't print the single quotes. But wait a minute, when I define my string, I use double quotes. And then when the interpreter tries to tell me that data is a string, it uses single quote. So are strings defined by single or double quotes? Well, strings are actually defined by both. So if I did do exactly the same thing, but replacing my double quote with single quotes, I get exactly the same outcome. So once the string is created, it doesn't matter if it was created with single or double quotes. Python will use single quotes. But that's the catch. It's once the string is created. So why is there this subtlety? Well, the subtlety is that sometimes you want some strings to contain quotes. So that's going to create a problem, right? Because how does Python know that the first quote that is appearing actually in the string, that you want in the string, that this first quote is not the end of a string? Well, the way you do this is that you play with the fact that you can use single or double quotes. So let me show you. If here I want to have a string that says, he said abracadabra, with this abracadabra surrounded by quotes, then I can use the quotes I want inside the string, and the other type on the outside to indicate that this is a string. Okay, so this is quite convenient sometimes. But then if you're thinking ahead, you know that sometimes you might want to have strings that contain a single quote and also a double quote. So what do you do in this case? Well, you don't have this easy workaround, which really this workaround is supposed to cover like 99% of the cases. So in this case, you have to use a backslash. And the backslash basically tells Python the next character is special. So the quotes can be preceded by backslash. But then you think a bit more and you're like, wait a minute, what do I do if I want to print a backslash? Because if I type a backslash, Python will think the next character is the important one. Well, it's true, but in this case, you just have to use two backslashes. The first one indicating to Python that the next character is important and that this next character happens to be a backslash again. Okay? So this is a bit complicated, and you will see quickly that how it works. Something else you can do with Python and strings is simply count the number of letters. So data was everything between A and J. So if you print the length, that's indeed 10. The next thing you can do is you can print specific parts of that string. So you can print the fourth entry or the entries between 4 and 6. Okay, so let's see that. So here I've asked Python to print the fourth entry, or at least I have passed the index 4, and Python has printed E. Wait a minute, E is the fifth letter of the alphabet. So there's a problem here. Not really. What Python is doing is that it's indexing strings, and actually everything, lists as well, starting at 0. So if you start at 0, 4 is actually the 5th index. So E is the 5th letter, but it's the one that's indexed by 4. That's a bit confusing, but you will see that actually for mathematical stuff, it almost makes more sense that counting starting at 1. It's only in the real world that we start counting at 1. Okay, so something else you can do is slicing. So this is called slicing, and it's selecting all the characters between the 4th index and the 6th index. So remember, this is really between the 5th and the 7th letter. And the output is EF. So some of you might have expected EFG. Why is it EF? Well, you should see this sort of like an interval that is closed on the left, open on the right, meaning the entry on the left really starts at the 4th index, and the entry on the right stops just before the 6th index. So something to help you is that the difference of the two indices here, 6 minus 4, 2 in general will be exactly the length of the output. Okay, and finally you can do slicing, but with missing parameters, either missing on the left, on the right, or at both locations. And this just means from the beginning or from the end. So if it's missing from both locations, it's really saying take data, make a copy of it from the beginning to the end, and I get a copy. Okay, so one aspect of Python that maybe is worth insisting on if you have experience with other programming languages is that a single letter string is also a string. So if I ask Python to print the type is a Python function, I get here that the type is a string. This is different from other programming languages that have a specific type for strings of length 1, which is called a character. So what can I do with strings? Well, let's first start with something you cannot do, and that something is assignment. So you can't take the string data, so remember data was this, and decide to replace a specific letter by something else. So I'll try to do that, and let's see what happens. So if I execute this, data3 equals D, I should get an error, except that I've put that into blocks try and except, and this is what's called a Python exception, and this exception was caught. So actually the error I was expecting happened. There was a type error, it happened, and so I went into this block where I decided to print caught a type error. Okay, so ignore the fact that there was an exception and all that. My point is basically that if I do data3 equals D, if I try to assign a specific letter to a specific location, Python will not be happy. And in this case, it will return a type error. Okay, so the exception caught this type error and it decided to do something else. The reason to put this exception in there is because I want the file on the left to be executable. So it would not be executable if it produced an error that was not caught. Okay, that's not very important. So what can you actually do with strings? Well, one thing you can do is you can concatenate them. So you can take two strings and take their sum, which just means put them side by side. So if part 1 is abra and part 2 is cad, I'll let you guess what part 1 plus part 2 plus part 1 is. And let's see, if I decide to print magic, it's going to be a string, which is exactly abracadabra. Once you have a string, you can find substrings. So you can ask where is a substring of magic that is equal to DA? And what Python is saying is that it will start at the 6th index. Okay? And this would return -1, which is of course an impossible value, if this substring was not found. Okay, another thing you can do is you can convert letters from lower to uppercase or from uppercase to lowercase. So here I've converted every letter in abracadabra to uppercase by calling the method upper on magic. That's very nice. Another thing I can do is I can split a string into different components, and I can decide the cuts to happen at a specific string. So I'll look in the string magic for the letter A, and I'll decide to split the string there. And I'll assign the output to split magic. And then I'll decide to print split magic. And this is the outcome. So this says really that there is an empty string before the first A. Indeed, abracadabra starts with A. And then there is BR between the first A and the second A, and then C until the next A, and then D, and then BR, and then again an empty string after the last A. Okay, so this is really abracadabra cut up at the A's, and it's returned as a list, and this is indicated with the square bracket, a list of strings. Okay, but once I have this cut up list of strings, I can decide to reassemble it. And let's say I want to put back in a triple capital A string. So I want to effectively rejoin the list here by inserting triple capital A between each component. And this is what I get. So since the list here started with an empty letter, I really have an empty, the empty string. I really have an empty string here, followed by triple capital A, then BR, followed by 3 capital A, followed by C, then 3 capital A, and so on. So this is split and join, and they're kind of dual to each other. All right, so that's nice. Another thing you might want to do is to manipulate strings or characters, individual one-letter strings, algorithmically. So to say start from one string and start from one character and jump by 5 to the character that's 5 later. Later for some ordering, and this will be the ASCII ordering that we use here. So that's done with the ORD and CHR functions. So ORD gets from the character to the integer that represents the order. So here I see that A is the 97th character for the ASCII ordering, Z is the 122nd, and indeed it's 26 later or 25 later. Capital A comes actually earlier, it's the 65th, and so on. And you also have non-letter characters, for instance $, which is the 36th in the ASCII ordering. Now the dual to ORD is CHR, and CHR takes as input an int and will return the string, which is of length 1 and just contains the character with that index. Okay, so here, and the detail is not so important, I'll create a list of length 1 strings, and each entry will correspond to a character whose index is between 32 and 126, okay, in order. So if I copy this, I then join the list by inserting empty strings between every character. So I should get a long string consisting of all the characters that have ASCII ordering between 32 and 126. So let's see. Indeed, you see this long string appearing there. And if you count, and if you start at 32 and you start counting from here, you will see that the A that we saw here had 97. So if you start at 32 here and you start counting, this A here should occur at 97. Why did I decide to print everything between 32 and 126? Well, the reason is that there are only 128 ASCII characters, so there's a bound above. And then I'm skipping some because some of them are not printable. Okay, so they would give me garbage here. So to avoid that, I just print between 32 and 126. Now, something that's more accessory, not so important right now, is that you want to do some string formatting sometimes. So I'm jumping a little bit ahead now. It will definitely rely on things you haven't seen, but it might be useful to know for some projects. So often you have some strings and you want to format them in some way so that it looks nice on the screen. And this is what string formatting is. So I'll give some quick examples. So here I want to print a string, and I want actually to first define a template where I can then input some values and replace some parts of the string with those values. So I'll first define a dictionary chord that will have two keys, latitude and longitude, with some strings that are the values of the latitude and the longitude. And then I define a template here. The template is indicated by using, so the entries in the template are indicating by using curly brackets. So I have curly bracket latitude, curly bracket longitude, and then I format it using the dictionary. And this will replace the key latitude by the value and the key longitude by the value. So the outcome here is another string where I've really replaced the template arguments by the values in the dictionary. So we haven't seen dictionaries, so maybe a bit simpler is this one. So dictionaries use keys, but this method here uses position. So with a curly bracket, I'll just indicate a double curly bracket with no content. I'll indicate the first and the second, then the third argument to format. So you see that this A here goes there, this B there goes there, and this C there goes there. Okay? And you can, if you reuse, it will not be very nice to just use position, so you can actually use indices, explicit indices. And remember, you start at 0. So here you're just saying, take the first entry of format and use it twice, and put in between the second entry of format, second for the human ordering. So you have abra, cad, abra, and this is the string that will be printed. Okay, so this might be relevant, this might be more relevant to you, and even more relevant maybe is this aspect now, and it's called justification. So remember, in Word you can left justify, right justify, center justify. So it's doing exactly this with strings. And the interest is that sometimes you want to print many lines, and you want those many lines to be formatted in some way. So for instance, you want some alignment between the different lines, and this helps you do that. So I'll do 3 examples. The first one is left alignment. So you want to take a string and you want to align it on all the way to the left, and this is done this way. You can also align on the right, but then if you think about it, you need to say how far to the right. So this is the 50 argument here. This is saying, take the string of input, I want this on the right, and turn it into a string of length 50, where I want this on the right is all the way on the right. So it will start by adding some spaces that are printed there. And actually, if you go back to the previous example, some spaces were inserted here, but you just didn't see them. Okay, so both strings here and there are of the same length, length 50. And finally, there is the center justification, where some space is added on the left and the same or within one space is added on the right, so that the total length is exactly 50. Okay, so that was for basic string manipulations. Later on we'll see more advanced string manipulations, but this should be enough to get you started with string.